Hello, everyone. Thank you for joining us today for our webinar, Why Clean Construction Doesn't Equal Costly Construction. My name is Mark Zacharias. I'm a fellow at Simon Fraser University and also a special advisor at Clean Energy Canada. And if you don't know us here at Clean Energy Canada, we are a think tank based at Simon Fraser University, but we have offices across Canada. And we work on many aspects of the kind of economic transition and climate action. But for today, as Canada moves forward with plans to build millions of new homes, the carbon emissions associated with the materials that make up buildings and other major infrastructure are quite substantial. Clean Energy Canada just released our new report, Building Toward Low Cost and Carbon, which finds that building with lower carbon materials and methods doesn't need to drive up costs, and even has the added benefit of supporting Canadian industries at a time of high tariffs and trade tensions. Now, first, some housekeeping while folks are connecting in. Firstly, if you have technical questions, you can ask them through the Q&A icon at the bottom of your Zoom screen. My colleague, Kira Torrance, will provide any support you might need. That's number one. Number two, we will be welcoming your questions in the final 30 minutes or so of this webinar. You will be muted, however, so please submit your questions through the Q&A icon. Feel free to ask a question at any time, as we'll be compiling them for later. And finally, our last kind of bit of advice, we will circulate a recording of this webinar and a copy of the slides to all who registered. Feel free to share them widely. We'll also include a link to Clean Energy Canada's really awesome weekly newsletter, which if you haven't already done so, please sign up for. It's a great resource that you will use a lot. Today, we are going to hear from an incredible panel with different perspectives on this issue. Just very quickly, in terms of introductions, I'm going to start with Ryley Picken, who is a policy analyst at the Treasury Board of Canada's Centre for Greening Government, and has acted as the technical lead over the last 3 years on the Government of Canada's Standard on Embodied Carbon in Construction. I'm also very pleased to introduce Juliette Cook, who is the co-founder of Half Climate Design, a research and design consultancy which aims to halve greenhouse gas emissions from buildings this decade. Audrina Lim, also very pleased to introduce, is the Director of Sustainable Construction at Chandos Construction, collaborating with industry partners to build a healthy and resilient low-carbon construction sector. And lastly, our very own Jana Elbrecht, Senior Policy Advisor at Clean Energy Canada. So how this is going to work is Jana will present the main findings of Clean Energy Canada's new report, and then we'll have a roundtable discussion joined by our other panelists, followed by audience Q&A. So to kick things off, I'll turn it over to Jana and to give her presentation on building towards low cost and carbon. Over to you, Jana.
Thank you, Mark. I will just, once these slides pull up, present some of our results from the report that we published in April. And there's quite a lot in that report, and I won't be able to go through all of the nitty-gritty details. So if you're interested after this kind of flyover, definitely encourage diving in deeper. See, there we go already. This is going too fast. Okay, here we are. So let me start by kind of introducing what we are talking about. And we talk a lot about the energy that we use in our homes to heat, to cool, to charge our EV. But what's talked about a little bit less is all of the energy and all of the emissions that go into constructing buildings and infrastructure in the first place. And those emissions are what we call embodied emissions or embodied carbon. And a lot of them come from emissions-heavy industries like steel, cement, and other building materials. And at Clean Energy Canada, we've been talking for a few years now to governments about what they can do to help. And one key policy tool is Buy Clean. So governments make up about a third of the market in Canada for construction steel, for cement and concrete. And so if governments start asking for cleaner materials and buildings, they can really move the market. And the federal government in Canada has already begun doing this for concrete and for steel, which I'm sure Ryley will tell you a little bit more about in the panel. But in these conversations, what came up a lot was, what is that going to cost? And will it increase the cost of building in a time when really we need to be, I'm now annotating these slides. That's not what I'm hoping to do. Can we go backwards, Kira? We're having a little bit of a technical issue, but I'll just keep talking. So in this report and with this research, we wanted to look at what the cost implications are of building towards lower carbon. And we studied two of the main strategies for reducing embodied carbon. So of course, what we build, the bottom of the pyramid here, is very important, whether that's suburbs, apartment buildings. But in this report, we wanted to look more at the top two pieces here, how we build and the materials we build with. And so we partnered with two great research partners that are on the panel today. I can only go forwards, not backwards, which is great metaphorically. So we partnered with Chandos Construction for studying the cost implications of using lower carbon materials. And we partnered with Half Climate Designs to look at what we can do with design. And all of this research is based on case studies. So these are real buildings that exist somewhere in Canada. So I'll dive into the materials piece first. And here, what's important to point out is we looked at like for like swaps. So swapping out a concrete mix for a lower carbon concrete mix. We're not talking about swapping out steel for timber. And these are, again, based on costing studies that Chandos Construction did in for buildings in Alberta and BC and in Ontario. And what we found really across the board was that in a lot of cases, lower carbon equivalents were available at the same market rates. So what that means is for, especially you can see here for drywall and for insulation, you can reduce emissions by up to 55%. Without paying extra. And the same goes in a lot of the cases for concrete, for structural steel, and for rebar. And there were some instances where we did find that there was a slight cost increase for a lower carbon equivalent. But here, one other thing that I want to point out is what that looks like for the whole building's budget. So even if we're talking about the very highest case for structural steel, a 25% premium per kilogram of steel comes to 0.16% of the budget. And here on the graph to the right, you can see sort of all of the data points for those of us who are more graphically inclined. And just to give another example of what this could look like. So again, the cost increases here on the right are per material unit. So when we're talking about a 7% increase per cubic meter of concrete in the cost for the whole project, in that case, it came to around $3,000. And we're talking here about a project that was tens of millions of dollars to construct the entire building. So we were actually, I want to say, positively surprised to find that for all of these case studies, you could swap out materials for their lower carbon equivalents and achieve a range of emissions reductions, most of the time without a cost increase. So that's a high flyer of the material study. And now I'll shift gears to talk about how we build and the design piece. So this was led by Half Climate Designs, and they coordinated a consortium of architects and engineers. And these are all based on real buildings that exist in Toronto. And so in each case, we have here the original design, and then what are some small tweaks or big tweaks that could have been made to reduce the amount of material that we need. So this first one is a townhouse. It's actually one of a row of 6 townhouses. And I won't go through every single intervention in detail. But here you can see that these are all, I want to almost say, cosmetic changes. These are, this is the same building, but the embodied carbon is cut by a quarter by doing things like using a different structure for the basement. Or instead of having these little framing pieces around the window, the architects realized that they could achieve the same result by using a different color brick, and visually it had a similar outcome, but you saved on materials, saved 9% of the emissions in the building. But we also looked at some bigger interventions. So this is a mid-rise apartment building in Toronto. And here the research team looked at one of the most carbon intensive things that we do when building, which is building underground. So here, the research looks at what would have happened if instead of building a parking garage underground, we would have built it next to the building on the plot. And here you can still imagine, you know, having a rooftop amenity here, having a garden to make it still kind of an engaging space. But just by kind of pulling that out of the ground, that in itself reduced embodied emissions by 23%, while providing the same amount of housing, the same amount of parking. And because building underground requires a lot more material, which is where those emissions reductions come from, but it's also, as you can see on the right here, saving that concrete and rebar alone is around $300,000 worth of material costs. And not unimportant in our housing crisis right now, building underground takes a lot of time. So by doing something like this, you can not only cut cost, cut emissions, but you can also shorten the schedule and shorten the construction time. And the research team even did this neat calculation of how many trucks of digging up ground it would be to build underground. But yeah, again, we also looked at some smaller things, like what if we use different materials for the window wall systems? So here's a range of options. Again, I don't have time to go into too much detail here. Just want to show that the final case study was a high-rise building. And this is a typical Toronto tower. So we've got underground parking, then we've got a few levels of retail, so shops, and then we've got, I believe it's about 600 apartments. And without getting too technical here, because all of these layers have different functions, they have a different layout. And stacking those on top of each other requires a transfer slab, which is essentially a very thick layer of concrete, which, as you can imagine, is expensive and emissions intensive. So here, the research team figured out that if they put the tower on the other side of the building, they could line up kind of the pillars in each layer a little bit better and eliminate a lot of that transfer structure that was needed. And here again, we estimated what that would mean in terms of saving concrete, saving rebar, which is in this case over $3 million. And again, 22% reduction in emissions. So even though we studied these two things separately, we do want to emphasize that savings are usually best achieved by combining them. And also in terms of the cost, by saving the amount of material that you need or reducing the amount of material you need, you might create a little bit of room in the budget, even if you have to pay a little bit more per kilogram of steel or per cubic meter of concrete. Yeah, so happy to go into more detail about all of this. So knowing that clean construction doesn't need to equal costly construction, what can governments do? The first and most important recommendation that we have in this report, and most of our work on this topic, is, again, that buy clean policy, making sure that any building, any piece of infrastructure built by the government is built to be clean, and to move the market in that direction. And we have some more detailed recommendations on how to do that, which we might go into in the panel. And for more the private sector side of things and project managers, it's really about thinking about carbon early on and making building clean a measurement of success in addition to cost as a measure of success, because that allows designers and construction teams to think early on about what the options are and make sure that these opportunities aren't missed. Yeah, and also encourage a little bit of creativity and thinking, how can we get the same function, but at lower carbon and lower costs? And I think I will leave it at that and move it over to the panel.
Awesome. Yeah, thanks, Jana, for that presentation. That was great. I'd like to now welcome all of our panelists to the discussion. And to kick things off, I've got a few pre-prepared questions, but after I will open the floor to the audience questions. So please, again, drop your questions into the Q&A box below, and we'll try and get through as many of them as possible. Now, to kick things off, I'm going to have a question put to the entire panel, and the question is this. With everything going on in the world, why is it especially important to talk about this right now? Who wants to go?
I could start. Hi, I'm Audrina from Chandos Construction. As we look at the amount of work coming through, not just around the idea of the concept of the requirement for affordable housing, we're about to use a lot of materials. And this is an opportunity for us in industry and our market to actually make sustainable long-term change and challenge the norms, our business as usual. And as we're shaking up all our supply chains, I feel like this is a really great moment, a point of inflection where we can actually make a difference and actually demonstrate to the world that this can be successful, and that we can actually have a significant impact via the construction industry, the design, construction, building owners, municipalities, all the levels of leadership. We can actually demonstrate how we can do this together. That's from me. Thanks.
Yeah, I can just pick up on that. I mean, I echo everything Audrina has said, and I think what's really critical is that decisions we make today, we sort of lock those emissions in, we lock that cost in, and on the emission side, that's for decades to come. And so if we're talking about 5 million homes or however million homes, it feels like right now we have this really clear opportunity to cut not just carbon, reduce costs, but also with sort of the ongoing tariffs, how we can support more local low carbon industries within Canada seems to be the really great opportunity that we have.
Yeah, I'll jump in to add that there's lots of opportunity to improve our carbon performance, right? So as the study shows, there's a lot of low-hanging fruit, and then also some sort of design-oriented approaches that can be taken at a very low-cost sort of way to make meaningful change, and then further drive demand for those lower carbon materials as well as sort of methods of construction.
Yeah, I should jump on that last point as well on supporting kind of Canada's clean industries. So of course, the market right now is very uncertain for a lot of these industries, and the government, the federal government, but also provincial governments here in Ontario have made really large investments in helping steel mills like those in Algoma and Hamilton electrify. And so it'd be great if then construction projects in Canada buy up that clean steel and build our new homes and infrastructure with it.
Awesome. Thanks, everyone. Okay, now a couple of questions specific to individual panel members. So first one is to Jana. So usually when we talk about low emission buildings, we talk about energy efficiency, heat pumps, et cetera, et cetera. So why should we be talking about embodied emissions too?
So yeah, it's definitely both. I don't want them to be pitted against each other. We need to talk about electrifying our homes, powering our homes with clean energy, but the embodied carbon piece of the puzzle usually gets a little bit overlooked. And just to give you an idea, for a Canadian home, it's about anywhere between 20 to 120 tons of emissions that are embodied in your home before you ever step across the threshold for the first time. And on the higher end, that's equivalent to 30 years of driving a gas car. So it's a real emissions impact. And as I think Juliette mentioned earlier, it's also all emitted right now and locked in. So we need to start thinking about buildings as a whole, and also maybe about some of the trade-offs. Do we do double pane glazing windows or triple? Where is the trade-off there in how much energy you save versus how much energy and emissions goes into making that material in the first place?
Okay, I'm going to pick on Ryley next. So the federal government recently updated the standard on embodied carbon in construction, which makes a terrible acronym. So Ryley, can you explain to us in plain language why it's important for governments to buy clean and what the policy does?
Yes, absolutely. So, I mean, I'll start off by apologizing for the long name. Leave it to a government employee to create something that needs an acronym. However, I do think the general concept is relatively simple. It's effectively a procurement standard. So it sets requirements that all federal government departments must apply to their procurements for design services or construction services to then incorporate the embodied carbon performance of those projects. So, very briefly, at the start of the project, any kind of major new building being constructed, as an example, would need in their design services contract, the designers would be required to estimate the emissions associated with that design and try to optimize it or reduce it by up to 30%. And then in the construction phase of that project, the concrete and steel that's being used in the project would need to, all the emissions associated with that would need to be disclosed, so reported on to the government, as well as an attempt to reduce it. And so we have sort of these sets of flow through requirements, all of which have sort of different application criteria. So we're not applying them to all projects, ones that will have a bigger impact. And trying to scope them so that they really make sense, so that they limit sort of cost impacts but maximize environmental impact.
Awesome, thanks. Audrina, you are on the ground building things kind of as we speak. So tell us, how far away are these solutions? That's the first question. And the second is, are low carbon buildings already being built in Canada? Second question. And the third one, are the materials available?
Well, yes, it's actually pretty exciting, and what a time to be able to be in practice. And I'll just say our team is doing incredible work, and they are taking on things that, and I think a lot of our teams, not just Chandos Construction, and I'll credit this to a lot of the GCs out there, learning how to do things differently. There are projects out there. I think the CAGBC has brought out the zero carbon building standard, and the city of Vancouver is doing amazing things with embodied carbon, and so is the city of Toronto. We have to have both an incentive and also a drive, a regulation drive to help us get there, so that we have an equal playing field so everyone can learn to participate. So I think it's actually exciting, because we see a lot more contracts going above and beyond for the ask to go for low carbon. And that actually brings us that challenge that we can enact on and still be competitive in the market, because we are a private business. We do have to make a living, and we have to support 850 odd employees, right? The good part about it is that we are learning, and we are doing a lot of investigation as to like what constitutes clean supply, what constitutes good materials, how do we source locally, mitigate the amount of transportation required. But it's not always super easy to do so, because we have cost challenges. As we see the cost of construction going through the roof post-COVID, and now disruption in supply chain, we have to be really cognizant of where are the benefits, what can we do differently that actually keeps us competitive, or we actually identify, hey, if we do this option that's low carbon, we can actually have these benefits and list them out X, Y, and Z, including embodied carbon. Now, as soon as we can get metrics and incentives against that, this is going to be much more viable, and we need a lot more advocacy and support around that, or we just need to have that standard set. For us, we're working on quite a number of low carbon builds. There's a few pilots actually in affordable housing that we're involved in. There are some large institutional buildings that we've already delivered that are going in for certification on low carbon construction or zero carbon design standard. And we actually have a few federal government supported projects, which we do report on our embodied carbon, on our concrete, our steel, and all our structural framing systems, as well as our envelope systems. So all of these things are starting to get accounted for, and we do our own internal modeling. So it's pretty exciting. The materials are available, and that market is only growing. Like actually right here in Calgary, just outside, our city, there's actually a net zero manufacturing plant coming for drywall, which is exciting for us because then it's local, it's low carbon, instant transportation, and there's supply. And for us, that's local Canadian jobs being reinvested, being supported by government, and that's what we search for, those opportunities to really optimize that impact. So sorry, very long answer, but 3 questions. Hopefully that was okay.
Great answer. Okay, Juliette, you get the inevitable question of, this is such an amazing thing, why isn't it all happening right now? So to set up the question, so the design case studies show that you can cut 1/4 of the emissions and save money through more efficient design. So if it's so easy, why aren't the architects doing this yet?
Well, to an extent, we did break some rules in some of the counterfactual studies that we did in the study. In places like Toronto, when you are building, you have to follow urban design guidelines, so things like setbacks and height limits and floor plate dimensions, etc. And these can sometimes result in inefficient massing. And some of these guidelines lead to things like high carbon practices of building underground parking, or having thick structural slabs or what have you, and that will then uptick the not just the carbon, but often the cost as well, lead to longer construction timelines. I think the construction industry as a whole tends to be risk averse, so we tend to like to repeat what has worked before. And so anything that is deemed new or different from what construction has looked like in recent history, also might scare people. We don't go that route. And so I think moving towards building codes that prioritize performance over kind of this prescriptive approach that we've been following in the last few decades would be really worthwhile. Right now, it seems like there's the current guidelines limit flexibility to designing lower carbon buildings. And so in some of the counterfactual studies, you'll see that we maybe are not following what the guidelines would require, which is what resulted in the initial buildings being that way. And then I think there's, outside of sort of the technical requirements of building, there's a shrinking, as Audrina said, we're all actively learning about these things right now, but still present knowledge gap. Many professionals are either not trained in embodied carbon or at least don't use carbon as an early design phase metric to consider. And so this early involvement is what's really key. Some of the material substitutions that Jana mentioned can have a great impact. If we think about the low-rise project, we weren't looking at major formal changes. It was really like material focused. And those can be introduced later on in the construction timeline. So they're still worthwhile investigations. But the bigger carbon reduction potential occurs in those earlier stages when we're making decisions about form and massing and structural systems. And sometimes that conversation isn't happening at that point in time. And so when that conversation happens later, inevitably the amount of reduction we can have for carbon is less, and also the cost is typically more.
Awesome. Okay, we've got time for one more question from me before we turn it over to the kind of questions from the audience here. And I'm sure someone's going to ask this anyways, so let's just get it out there. And just one of you or all of you can answer however you like, but very briefly. So the report from Clean Energy Canada, addresses the concern that low carbon construction would cost more. But what about time? Will a focus on embodied carbon reduce the speed of our housing build out? A very timely question. Who wants to volunteer to go?
I mean, I can get a start on it. So I think obviously every project is a little bit different due to its location, the materiality of it, etc. But from my understanding, it looks like that there's not necessarily any time impact. And so there certainly can be for certain things, right? So pouring lower carbon concrete sometimes involves a longer curing time. But that doesn't necessarily cause an actual project delay if that's been planned for in advance, right? And then conversely, an increase in prefabricated construction might very significantly speed up the time of on-site construction, right? And so it really depends on the design itself. But I mean, that's where I would start the discussion.
Anybody want a hot pursuit?
I can jump in just from the construction timeline side. As an organization and us alongside a lot of other GCs, we track our related emissions during construction and we report that out. What we're seeing is if we can actually shorten construction time, start looking at panelization, prefabrication, we can actually enhance the amount of embodied carbon saved on that building because we're not having to do it manually on site. So technology is going to help us get there, but we also have to have contracts that allow us to be creative in the actual construction side of things as well. For us, paramount is safety. We have safety that comes first, and that takes time. But if we can have controlled environments where safety is guaranteed, guess what? We can move faster. If, as per the research, if we don't have to dig and we don't have to look at shoring and below grade issues, that saves us so much time, and we can actually have things engineered to be prefabricated, pre-assembled, and built on site with a lot lower emissions. And within that manufacturing as well, if it's being done off site, it could be using clean energy instead of diesel generator to energy to actually manufacture and create these things. So for us, we see a lot of potential, and we see a lot of design strategies that can enable that. We just need the right contract set to enable us to get there as well, and the right early involvement so that we can participate in that whole design and engagement process as we make decisions 1 or 2 years in the future, right? So we have to be able to have everybody's voice at the table, understand how or the objective, and we can also pitch in as to like, hey, we can actually do this much more efficiently by switching or tweaking just this little bit. Just to Juliette's comments before, it goes to design and designing of the construction strategy too. So yeah, I'll leave it at that.
Awesome.
I'll just add, I think Ryley and Audrina mentioned everything that sort of popped into my mind when you asked the question, but if anyone was at the University of Toronto GHG symposium last week or the week before, the focus this year was really on the notion of sufficiency, so designing for what you actually really need. And I think when you bring that notion into a project and you design for the sufficiency, repeatability, and simplicity that Audrina was just alluding to, that Ryley was also speaking about, that will for sure improve on speed and budget simultaneously.
Great. No, that was very helpful. Thank you very much. Okay, we've got some great questions from the audience here. So I'm just going to roll into this, and we will get through as many of these as we can in the next kind of 20 to 25 minutes. Okay, first question. Maybe this is to Jana. Are you talking to other governments about this work? What sort of response are you getting?
Yeah, we've talked to the federal government of Canada a lot about this work, and in fact, they supported this research as well. Got some great support from Ryley and his team and some other departments, and they're actively working on this. So the response has been very positive, and I think especially now that we can show that it doesn't need to cost more, we're hoping that will mean that maybe those buy clean policies will be expanded without, putting Ryley on the spot here on the panel. Yeah, but we are also definitely talking to provincial governments about it as well, because a good chunk of that funding for buildings and infrastructure is on the federal level, but even more of it is on the provincial and municipal level. So we're definitely also talking to provinces about buying clean. And I think the fact that we can show that, one, it doesn't need to cost more, and two, that Canadian materials made in Canada are often cleaner than imported materials, so that buying clean often means supporting local industry, has also helped us speak to governments about that and creating support for that policy.
Great, thanks, Jana. Okay, next question is kind of probably for anyone on the panel here, maybe a little bit more for Ryley or Juliette, but the question is, can local governments mandate that developers use clean construction materials?
Yes. Yeah. So, I mean, different levels of government have different sort of levers and jurisdictional sort of oversight. But I think there's some great examples across Canada already in terms of certainly the city of Vancouver and the City of Toronto both require sort of whole building life cycle assessments for a large number of projects that occur within their city, and are starting to integrate reduction targets. And so that's nice because it's also a performance sort of based approach, and a relatively holistic design sort of oriented approach to reducing embodied carbon of your project, as opposed to targeting, a very prescriptive sort of solution of a single material at a time. And then there's other examples like the city of Richmond in BC, who does have requirements specific to concrete, and other like even non-government organizations, right? University of McGill, University of British Columbia. So there's lots of organizations across Canada that have already started to establish requirements specifically for this, for their own, either their own operations or within their own jurisdictions.
Anybody want a hot pursuit on that? No need to. We have lots of questions. Okay, next question here is, as we are pushing to become an energy superpower country, phrase used by politicians of all stripes, what does this mean for housing companies that use steel and lumber?
I think I might repeat my point on supporting Canadian industry to be future ready, because another report that Clean Energy Canada put out recently was looking at export markets and showing that, when we look beyond the US, almost all of our trading partners have carbon pricing in place, have net zero targets in place, are moving towards clean economies. And so if we want our industries to remain competitive, we need to start thinking about that, and we need to electrify our steel mills. We need to invest in net zero drywall and concrete. And so supporting industries to do that helps us future-proof our industries.
Great.
I was also going to jump in as
Yep.
well for if we can have some level of repeatability, we can actually push industry to right size and eliminate waste. Waste is a huge thing that we haven't even touched on yet, but the amount of materials that it takes to build what you think it builds on site, there's a lot that you don't see. And if we can talk about modularity and efficiency and sufficiency, we can actually start to optimize the use of steel and lumber and have it, the right sourcing, the right sizing, and making sure that like customization doesn't overtake the priorities that we have for the housing emergency. We need to understand what that looks like. What is transportable in our current infrastructure? Why are we designing beyond what is readily available for scale and size and measurement? I think these are real key things so that we can optimize our resources for the best use case scenario. And that doesn't eliminate the use of steel and lumber. I think it just encourages it more to be more efficient, more effective, and we don't have as much processes associated with gaining the actual product, the house or the accommodation, if that kind of resonates. Yeah.
Great.
I can jump in, but I don't know if there's a question that's going to lead to what I was maybe going to discuss. And if so, hopefully this addresses it too. I think another piece to this conversation that we touched on very lightly in the report, there was one instance of reuse where foundations in the Tall project were reused, and it led to, I think, something like 98% embodied carbon reductions through the reuse of the foundations. So we didn't have to introduce new shoring, we didn't have to demo those existing foundations. And I think the reuse of buildings at that scale, as well as the reuse of materials, though the material reuse may be a small part of the solution for all the construction that's required in the crisis we find ourselves in, I think it's still a worthwhile investigation, particularly in lower, low-rise, multi-unit, low-rise, single-family home applications. And so how we're introducing building code pathways for existing buildings, which apparently are coming out in the near future, that prioritize reuse and retrofit strategies, developing compliance options for reused materials more generally, as well as more regenerative materials, bio-based construction, I think are other ways that we can, support more locally made products. If anyone in the audience has any agricultural waste that could be funneled into the construction industry. I think those are really exciting opportunities that would future-proof our construction industry and make us more resilient.
Great, thank you. Okay, there's some really good questions here in the chat, so I'm just gonna hop around a little bit, kind of based on some of the discussion here. Next one, maybe it's for Juliette, but the question is, how much of the options in the work is reflected in currently available certifications like LEED or building standards?
How much of the options in the work is reflected in the... I would say LEED certainly can lead, pun intended, to some of the outcomes that were found in the report. You know, again, I would call back to my earlier point that the existing buildings, so the kind of case 0 in the report of each case study, we just purely went with how those were built, which was determined by the urban design guidelines. And so there's limitations with how much LEED can deviate from these design guidelines that exist and require them to be met. I also think a LEED system where not take issue with it, but where there's sort of concern is that often you can pick and choose the parts of LEED that you want to that are maybe easier for you to achieve in order to achieve that LEED status. I think that, this really picks up on a critical effort that is required, that is the development of embodied carbon methodologies, assessment methodologies, standardization, and how the people that are building the buildings are doing those assessments, and really ultimately how we're moving towards more of a unified understanding of how buildings are performing. So we're not seeing the operational performance as something separate from the embodied carbon, and really trying to understand how the two work together. In some places, Scandinavia in particular, Denmark has a whole life carbon metric. So they just give you one number, that's your target, and you can do whatever you want within that budget. Pick a really carbon intensive HVAC system, but very low carbon materials, or vice versa. But it's forcing the conversation to be less siloed and more collaborative.
Great. Well, we have lots of questions here. I'm not sure who would like to take this next one, but it's a really good one here. Are there any carbon financing options or carbon markets enabling financial support for these types of initiatives?
I would love to hear about one. Well, from our projects that we have, we see these projects who are targeting lower carbon builds, they actually do get more financing and funding. And for things like the FCM grant, where sustainability is a priority, if you can gain a zero carbon building certification, you actually get to the top of the applications, right? So it's incentivized, I would say. The carbon markets has been such an interesting space, and you guys actually, Mark, you probably know with all the think tanks and what you guys are sort of researching and how it relates to policies and politics. But I still believe that there are objectives here. Like Jana had mentioned earlier, this is an international scheme. There are carbon trading platforms in the market, and Canada should absolutely jump on board to try and bring more investment, especially when the neighbors to our south have kind of turned a blind eye towards that. There is investment money out there that's going to look for clean projects to invest in. And I think this is our opportunity to bring that money to Canada.
Anybody else want to weigh in? You don't have to.
I think just on the carbon financing, carbon credits specific to like bio-based or natural building materials, I think the idea with these materials is that they sequester carbon. It's really important to, one, consider that the carbon that's sequestered in these materials is only sequestered until that material is either the end of life scenario. So if it's reused at the end of life, great, that carbon stays locked in place. But if it's incinerated or landfilled, it's a different story. So that's one side of it. I think really, again, if we go back to this idea that what we're emitting is sort of right now, and it's what we're emitting. There's the sequestration side of it that I think should act as a credit in some form, but really we should be looking to reduce our emissions as much as possible first, and then look to any kind of offset benefit next.
Great. Okay, next question, kind of looking at the time, would love to get through a couple more of these. Maybe this one's for Jana. Does the study look at any employment and labor-related cost impacts for bike lane policies?
We don't quantify any of those impacts in this study. So we have done, Clean Energy Canada has done a study a few years ago now on job creation in the clean economy, showing that a clean economy has more jobs than a fossil fuel economy. And some of those jobs are in, clean steel supply chains. What we did look at a little bit in some of the more interview expert engagement parts of this research, which I didn't really talk about in the presentation, was what is this going to look like for people on site? And I think what a lot of the expert opinions were that a lot of this can be done without, on the material use, a lot of this can be done without extra training. You pour a concrete mix kind of a similar way, but maybe on the more professional, rather than the trade side, I think Juliette mentioned this as well. It is about capacity building among engineers and architects, and kind of making sure that that embodied carbon angle makes it into training programs, makes it into degrees, so that there is creativity to pursue the lowest carbon option for buildings.
Great. Okay, next one, maybe this was for Ryley to start here, just given kind of what you may or may not be hearing from the incoming federal government. So the question is, what new emissions reductions incentivization programs do you anticipate with the new federal administration, especially for affordable housing?
Yeah, so still pretty new administration, so I can't say that I have a holistic picture of what our future will look like by any means. I am familiar, however, that, for instance, Housing, Infrastructure and Communities Canada is starting to build out buy clean policies or requirements into some of their funding programs, including for public transit and housing funding. And so that would be like a really big sort of, I guess, expansion of sort of buy clean from the federal government perspective, and certainly could have an impact on that. Sure.
Great. Okay, and our remaining kind of 3 minutes before the lightning round, we got kind of one more question we have time for. It's a bit of a longish one, so let me read it, and I'm happy to read it again. So the question is to the group. How do you think we can best balance the need to pursue ambitious, new or newish, low carbon and resilient building solutions, while also allowing for repeatability that can often help encourage affordability and help build confidence and competence for builders on the ground? And then just kind of a follow-up point here, to allow for this balance, must we adopt new processes or technologies such as offsite construction, or shifting mindsets such as sufficiency in design, etc.? Who would like to field this one?
I can jump in and kind of throw it to Juliette maybe, because one of the cool things that I've seen recently, so the CMHC put out the standardized design guide, and I think that's a really great example of how can we standardize construction and speed it up. And then if you make sure that in that design guide, you think about embodied carbon, and maybe with that, I'll throw it to Juliette to not talk her talking points.
That's great. I mean, I was actually thinking if I was going to piggyback off of Ryley's last response, I was going to mention the CMHC Housing Design Catalog, which is sort of being released in phases as we speak. And, I think that sometimes there's some concern when people hear the word standardization that you're ignoring the local context and climate risks and all these aspects. And of course, that's a concern and was, we hope, addressed in some of the analysis that was done to lead to the designs that were then published. And some of that documentation that HAF specifically worked on has not yet been released yet. So that will be coming out, but the thinking about both the operational performance, the embodied carbon of the designs that were proposed was at the forefront. In fact, if you choose to build one of these homes, you'll get a full report with how your building is performing. And then there is supplementary documentation that ideally will guide you if you're hoping to make a reduction on one side or on another. So that's certainly one area. I'm sort of forgetting parts of the other questions. So Audrina and Ryley, if you have anything to add, please do so, and I'll go back to the chat and reread.
Yeah, I mean, I would say that a lot of the building blocks are there. Certainly there's a need to accelerate housing construction and at the same time still pursue it in a low carbon way. And I think that both are still possible. It's a challenge for sure. I would say one simple example of a change in mindset that we would need is to really minimize below grade construction as an example, right? So that can make a huge difference on the embodied carbon. It also speeds up the construction considerably. Uses less overall material and that kind of thing. So that would be one example, but certainly further standardization in design for Part 9 buildings, like through the catalog, but also, I guess, I would say that prefabrication, modular construction and stuff will also have an increasingly large role to play in terms of just being able to scale up that supply to the extent that we need.
Great. Thanks, everybody. And, apologies to those who put questions in the chat that we were unable to get to. I would suggest that you connect with the panelists directly through email or other means, LinkedIn, whatever, and just kind of continue this discussion, because there's lots of really good questions that we did not get to as well. But also I'm hoping that we will get all questions kind of back to everyone as a follow-up to this. But in our remaining couple of minutes here, this is what we call the lightning round. And the question is, through the panelists, if you could wave a magic wand, what is the one thing you'd like to see happen? What do you want governments to do? What do you want industry to do? So very quickly, this is the magic wand question, and I'm going to randomly start with Juliette.
Thanks, Mark. I think that I would love for governments to adopt performance-based building and zoning codes that would allow for more flexibility in achieving low carbon and perhaps alternative design solutions than what we have seen recently. And then I think as an industry, this is sort of government related still, but expanding buy clean policies federally and provincially, and how that leads into industry is where we can really focus on strengthening Canadian manufacturing. I kind of alluded to this earlier, but I think there's a really great opportunity to look inwards and see what, if we really had to source within Canada, what can we get and what can we not get? And where are those gaps? And how do we fill them if we wanted to source within our own borders? And then especially around things like bio-based materials. So hemp, straw, mycelium, what does that look like if we are to start building with those kinds of materials within Canada? I'll leave it at that.
Who can I pick on to go next? Audrina.
Oh, hey. I actually think support for good data, because that informs us of, what we're actually trying to achieve here, and not just chasing, like the next hot thing. We need real data, and we need support for certifications to enable new materials to get into the market and to participate in this sort of environment. Like, there's so much we have to consider, like fire rating testing. We have to look at all the durability. We need to have a better balance and a better understanding and be able to diagnose and improve as we evolve. So data drives that. And right now, the data is somewhat sporadic. And if we have a little bit more analytics, we have a little bit more research and information and supporting teams like yours to continue doing the good work that you do, I think we have a really, really bright future ahead. That's me.
Great. Ryley, any last thoughts?
Yeah, I've got two. So really just accelerations of trends that I'm already seeing. And so one would be, an continued sort of adoption of buy clean policies across different jurisdictions in Canada, provinces and municipalities alike, to really help sort of increase sort of the rate at which we can affect this change. And then a continued sort of collaboration between government and industry on industrial decarbonization. So there's been some real significant investments made, both by federal government, provincial governments, and industries themselves to start developing their roadmaps on how they're going to achieve net zero. And we really, we can't necessarily just replace all materials with other types of materials. Some high intensive materials like carbon intensive materials like concrete and steel are going to still be needed. And so how do we drive down the emissions of that production? So.
Great. And batting cleanup is Jana.
Always hard to go last, but since it's a magic wand question and I get to dream big, I think I would say putting in essentially an embodied carbon budget in the building code, so that any building built in Canada, whether it's built by a government or a private actor, has to think from the start, here are all of the emissions I get to have in this building, and think of creative solutions to use that budget best.
Great. Well, I know everyone's probably got a meeting in the next 5 minutes, so we will end this, but I want to thank our panelists for a great discussion today. Thank the audience for all your questions and for making the time to attend. And thanks to Kira for kind of setting us up and getting this functioning beautifully. As discussed at the outset, we will get everything, slides, materials, copy of what we've done today. We'll get it back to everyone who registered. And thank you very much. Have a great day wherever you're from.